Okay, we're ready to take a look at another DIVA problem, 2015 AP number 3. Once again, the highlights of the DIVA problem are the following: displacement, velocity, and acceleration. You find each unit going down by taking the derivative. You find any unit going up by integrating. Derivative down, integral up. Key things on DIVA problems that always come up: remember the difference between speeding up and slowing down. You have to look at both velocity and acceleration. If they're the same, that's speeding up. If they are different, that is slowing down. Remember, often on these problems we're given velocity to start out with. If we integrate velocity, we get displacement. That just tells us where we are. If we start out with velocity and make them all positive and integrate that, what we end up with is distance traveled. Okay, let's go on to our problem. Okay, so here we have, it says Johanna jogs along a straight path, and her velocity is given by the table up above. So even before I look at the problem, I know I'm starting with velocity. The derivative of that is going to be acceleration, and the integral of that is going to be displacement. We've got selected values, and he says use the data in the table to estimate the value of v prime of 16. Okay, so do they want me to take a derivative or do they want me to take an integral? Well, they want me to take a derivative because they're asking for v prime, and I can estimate slope using fib phi. Now the question is, which points am I going to use? Well, they want me to be estimated 16, so I'm going to use these points right here. And I'm going to say that v prime of 16 is approximately equal to, on the bottom I've got 20 minus 12. On the top I've got 240 minus 200. I can leave it right there. It doesn't ask me for units of measure. I'm not going to put any of that down. If you really need to know what that was equal to, that's 40 over 8, which is equal to 5. And I don't need units of measure, but what they would be, if velocity was meters per minute, this would be in meters per minute squared, because I'm going down 1 unit. Okay, let's go ahead and take a look at the next question. I can already see integrals coming into play. It says, using correct units, explain the meaning of the definite integrals 0 to 40 of v of t in the context of the problem. So as we said before, if we start with velocity, if we make it positive and integrate the velocity, we're going to end up with the total distance traveled. So for part B, I would write down that the integral from 0 to 40 of the absolute value of v of t dt is equal to the total distance traveled from t equals 0 to t equals 40. I've done that. Oh, but it says using correct units. That's okay. If v was in meters per minute, integrals make rates go away. Total distance traveled, t equals 40 in meters. So that's the first part of that problem. And then the next part says approximate the value. So once again, you notice here this was estimate the value. That's why we found the slope. Now it says approximate the value of this using right Riemann sums with 4 subintervals indicated in the table. So in order to do that, all I'm going to do is I'm going to draw myself a picture, but I'm going to take any velocities that are negative and I'm going to change them to positive. Now I can't really fit it in on this page, so I'm going to go to another page to make a chart. Hang on one second. So here I've written down the x values they gave me. I don't care about how they're spaced out. I'm just going to keep heights approximate. So at time 0, we're at 0. At time 12, we're at 200. At time 20, we're at a velocity of 240, but I'm putting in the absolute value of. At time 24, we're at a absolute value velocity of 220. And at 40, we're at a height of 150. The heights of these numbers don't necessarily matter, just as long as I can see what they are. And now I'm going to do Riemann sums, which means I'm going to start from I'm going to see what kind they want. They want a right Riemann sum. And a right Riemann sums means I'm going to start on the right side of the problem and just draw rectangles. And I always just draw them first. I use the first height here and draw. Here's my first. Second height, draw. Third height, draw. Fourth height, draw. So I have my information for my Riemann sums, and now in order to find those rectangles, I usually fill the information in. They wanted 4, and sure enough, it worked out to give me 4. So I'm going to say we know that this height is 150. I've got to find the length of these intervals right here. This is going to be, okay, so I've computed out the values of the size of the interval. So now I would say that the integral from 0 to 40 of v sub t with an absolute value sign on it, dt, is approximately, the first one is going to be 12 times 200 plus 8 times 240 plus 4 times 220 plus 16 times 150. You can leave it just like that. You don't have to compute out the answer. Just so you know, I added them all up, and I get 7600. If you really wanted to, and you didn't want to do this math right here, you don't have to. You could have rewritten this, instead of writing down the number 12, instead right there, you could have written 12 minus 0, the length of the interval. It doesn't matter, but I think it's easier to find the lengths of those intervals so you can see your answer. Remember, I started on the right side because it was a right Riemann sum. So one height is not going to get used. So I've used the rightmost height, the 220, the 240, and the 200. The last one doesn't get used. It always happens on a Riemann sum. Okay, part C says some other guy, Bob, is riding his bicycle along the path between 0 and 10. Bob's velocity is modeled by this equation right here, where it's measured, t is measured in minutes, and b of t is measured in meters per minute. Find Bob's acceleration at time t equals 5. Okay, well, if I know that b of t is velocity, I'm going to write it as v of b, just so I know what's going on here, is t to the third minus 6t squared plus 300. Okay, so from here I can find Bob's acceleration, which would be a of b, equals 3t squared minus 12t. And to find his acceleration at time t equals 5, a of 5 equals 3 times 5 squared minus 12 times 5. Want to leave it like that? Go for it. Does it ask me for units of measure? It does not, so I'm not putting them down. If I did want to find that answer, that would be 25. 5 squared is 25 times 3 is 75 minus 12 times 5 is 60. That's equal to 15 meters per minute squared. Remember, it doesn't ask for that. I don't have to do it. I could have ended this problem right here. Could have ended it right there. Okay, on to the next part, which is a slightly new topic for us. I'm going to pre-teach it in this video, and then we'll talk about it in class. Hold on a sec. Okay, the last question says, based on the model B from part B, find Bob's average velocity during the interval of time that's given right there. So it looks similar to the problem from the beginning where they asked me to estimate something, but we're going to talk about average. There's two types of average things we can find. I'm going to go to another page for a second. We can either find what's called an average slope or an average rate, and we know that's always going to be fib faba. It's always going to end up being fib faba. Okay. Now there's another type of problem we're going to see coming up. You'll see why it's really not that much to it, but they will often ask us for an average value. An average value is different from average slope. Average slope, 2 points, fib faba. Average value is asking you the following. I'm going to turn the page for a second here. Let's say that we wanted to look at Josh's average value or average score in a class. How do we find his average score in a class? Well, what we would do is we'd line up all his tests, line them all up. (90, 68, 93, 23, 24. Not a good one there, Josh. And how would we find the average? We would add these all up. We'd add 1, 2, 3, 4, 5, 6, 7. We take all those numbers. I'm going to not do the right number here. Don't worry. Let's say they added up to this. So I'd find out what they added up to, and then I would divide by how many tests we had. 1, 2, 3, 4, 5, 6, 7. We would divide by 7, and that would give us our average for the course. Okay? That's pretty much how averages work on functions. I'll show what I mean. I'm going to sketch a function here. And this function, let's look at it here. Let's say it starts at A, and it goes to B. Okay? Let's say this height is 10 right here. The values of the graph are every single point between this one right here and this one right here. And you can think of it this way. The value of the graph at A is 10. Okay? The value of the graph at B is, let's say that was 12. Let's take another point. The value of the graph at this value C, let's say that is 8. Well, let's say we wanted to estimate the value of the graph. What would you do with these right here? Oh, you'd take the numbers you had. You'd take the 10, the 8, and the 12. You'd add them together, and then you divide by how many points you had. You would divide by 3 total points, and that's how you find average value. But I don't want to use just those sample points. The way we really want to do it, if we want to add every single value there, all the ones in between, adding them all up, and then divide by how much distance we covered. Okay, so the tool for adding in calculus is integrating. If I have this function called f of x, and I integrated it, x dx, starting at A and ending at B, I would actually have a sum of all of the values on the graph. So that's like that adding all together part that we're going to work with. Now, how would I find the average? I divide it by how many points I had or the distance that I covered. The distance that I covered is from A to B. So often we will then just take that number, that distance, which is B minus A, and put it on the bottom to divide it on out. The shorter way of writing this equation for average value is equal to 1 over B minus A times the integral from A to B of f of x dx. This is how we say average value. Average value, not slope. Here's the function, and they want me to integrate it. And this is like pretty much a level of integrating they want you to do when you have a problem like this. This is equal to 1/10. I'm going to make a set of parentheses. The integral of t to the third is 1/4 t to the fourth minus t to the third, 6 over 3, plus 300t from 0 to 10. Now, you do have to write it all the way out, but you don't have to solve it anywhere from here. I'm going to write out what this answer is going to look like. I'm going to do upper minus lower, 1/10, parentheses 1 over 4, 10 to the fourth, minus 6 over 3, 10 to the third, close that parenthesis, plus 300t, 310 times 10. I'm going to close that parenthesis. And I'm going to fill in the 0, minus 1/4. I have an extra set of parentheses here. Hold on. No, I think I'm good. 1/4, 0 to the fourth, minus 6 over 3, 0 to the 3, plus 300 times 0. They will very often use 0 as a number. You can leave your answer fully like this. You don't have to simplify it. If you need to see what it looks like, all this part at the end here, all of these, that becomes 0, 0, and 0. So we get 0 for that end piece right there. If I really wanted to fill it in, I could fill in a little more. I could say the 1/10 is on the outside. 10 to the fourth. Problem would simplify into this right here. Once again, you could stop right at that line right there. You don't have to go any farther than that. I'm just doing this just to see what it's going to be. This is 1/10 times 10,000 over 4 minus 2,000 plus 3,000 is going to give me 1,000. I'm going to distribute my 1/10 in there. I'm going to cancel that, cancel 1 0 there, cancel that. And I get 1,000 over 4. And 1,000 over 4 is equal to 500. Oop. Realize I had a quick signage issue right there. So 1,000 divided by 4 is 250. Oop, wrong pen. Is 250 plus 100 equals 350. Once again, doesn't need to be done. You can stop right there. The key new thing for today is about average value. Remember the difference between average slope, which is just fib-faba, and average value is the integral of a function over that interval that adds up every value in there, and then you divide that by b minus a. There you go, folks. Okay, you can write that in your packet, and I shall see you tomorrow. Take care.